I was actually digging through some old boxes this weekend, and I found this really old sketchbook of mine.
Oh, nice. Like high school art class stuff, or?
Yeah, exactly. Just flipping through pages of things I drew years ago. And I found this one drawing. It honestly wasn't even that good. Just a basic pencil sketch of a guy standing on a cliff looking out at a city. But looking at it, I remembered exactly what I was feeling when I drew it.
You remember the whole world behind that one image.
Right. I remembered that the wind was supposed to be blowing really hard. I remembered the city down below was supposed to be loud, like full of sirens and traffic and chaos, and the guy was shivering. But looking at it on the page, it's just dead. It's just graphite on paper, frozen in time.
Yeah, that is the tragedy of the static image, isn't it? I mean, it's the universal struggle of basically every visual artist, from early cave painters to modern digital illustrators. You have this incredibly vivid, kinetic, breathing world inside your head, like a full movie, really. But your hand can only capture a single static millisecond of it.
It's kind of like taking a photograph of a fireworks display. You get the light, but you completely lose the boom. You lose that sense of awe.
Precisely. And for centuries, the gap between that internal world and the external output has always been bridged by the viewer's imagination.
Yeah.
As the artist, you're basically asking the viewer to do the heavy lifting. You're saying, please imagine this is moving. Please imagine the wind.
But today, and this is why I'm so excited about our topic, today we are talking about literally closing that gap. We're talking about taking that old sketchbook, scanning that page, and stepping inside the drawing, turning it into a digital masterpiece.
We really are. We're doing a deep dive into this incredible convergence of some very dense academic research and some surprisingly gritty grassroots experimentation.
Yeah, we've got a great stack of sources today for you listening. We're going to be unpacking a specific academic paper called the Filmmaster Study, and we're pairing that with expert community guides, specifically the super grok users on Reddit who are just brute forcing these tools to see what breaks.
And both the academics and the hobbyists are aiming at the exact same target, turning a static drawing or a generated image into a consistent long-form narrative world.
And when we say long form, we definitely don't mean a 3-second GIF of a waterfall that just loops forever.
Nah, definitely not. We mean an actual story. A sequence where a character moves, they interact, they change emotions, and the world actually remains stable around them.
Which is the core mission of this deep dive. We want to crack the code of long-form AI storytelling for you. We're going to look at some fascinating case studies, too. A little Prince-inspired journey through space, a vintage postcard coming to life, and my absolute favorite, a rough sketch of a tank turning into a photorealistic battlefield.
Oh, the tank example is phenomenal. It really changes how you view the whole medium.
It does. But before we get to the magic, we really have to talk about the curse. Because anyone listening who has played with these AI video generators recently knows that you hit a wall incredibly fast.
Yes, the dreaded 6-second barrier.
Right, the 6-second barrier. I see this complained about all over the Reddit threads. People say they get this amazing, gorgeous 4-second clip, but the minute they try to extend the timeline, it just turns into an absolute nightmare. So why 6 seconds? Is that just an arbitrary server limit these companies set, or?
It's not just a server limit, no. It's much deeper than that mechanically. Think of current AI video generation like a really vivid dream. When you're dreaming, you can see someone's face perfectly clearly. But if you look away for a second and then look back, the face has changed. Maybe their nose is different, or suddenly they're wearing glasses.
Because the dream doesn't actually have any memory.
Exactly. It has a very short context window. The AI is generating pixels based on probability. For the first few seconds, that probability is tightly controlled by your prompt and your starting image. But as time goes on, usually right around that 6-second mark, the mathematical noise, the randomness that actually allows the AI to be creative, starts to drift.
So entropy basically just takes over the video.
Entropy always wins. The consistency crisis sets in. So you might start with a boy on an asteroid. At second 4, he's a boy. At second 7, his scarf changes from red to blue. And by second 10, he might have aged 20 years or just turned into a generic astronaut.
The character lock just completely breaks.
It shatters. And that's exactly what we're solving today.
Right. We are going to unpack the specific workflows from the high-level academic theories to the messy hacker tricks to break through that 6-second barrier. We're going to figure out how you force the AI to remember exactly who your actor is and where your stage is.
We're basically going to train the AI to stop being a dreamer and start being the director.
I love that. So let's start with the spark, that initial moment where the static sketch becomes a world. I want to jump right into that tank example I mentioned earlier because for me, reading through the sources, that was the real aha moment.
Yeah, this comes from the grok community on Reddit,
Yeah.
specifically from a user named Razmadrak.
Now, I really want to paint a picture for you so you can visualize this.
Right.
When I say sketch, I do not mean a polished Da Vinci study. I don't mean professional concept art. I mean, well, the user themselves admitted it was a bad sketch.
It was essentially a napkin doodle. Wobbly pencil lines, basic flat perspective. Honestly, a child could have drawn it.
Right, it's just a tank. You can tell it's a tank because it has treads and a barrel, but that's pretty much it. It's sitting on a blank white background. But then they fed this ref sketch into the AI with a very specific prompt.
And the prompt was the key. They didn't just type, make this tank drive forward. They wrote something like, it's an epic World War II scene. The tank breaks through the paper drawing and turns into a photorealistic live-action scene.
And the resulting video, honestly, it gave me goosebumps. You literally see the white paper, you see those wobbly pencil lines, and then suddenly the treads start to churn. But they don't just move, they actually gain physical weight. They get covered in thick mud. The shiny pencil lead morphs into heavy steel. And the white paper literally tears open to reveal this chaotic battlefield behind it.
It's a literal breaking of the fourth wall. But what's truly fascinating here from a creator's standpoint isn't just the visual trick of it, it's what this implies about the changing role of the artist.
Let's unpack that, because if a quote-unquote bad sketch can create a photorealistic blockbuster movie, does that mean technical drawing skill just doesn't matter anymore?
No, it doesn't mean skill doesn't matter. It means the specific type of skill has fundamentally shifted. Think about the traditional animation workflow. If you wanted to animate a gritty tank battle from scratch, you needed to be a master renderer. You needed to understand exactly how light refracts off dirty, scratched metal. You had to understand the complex particle physics of smoke and debris.
You needed years of technical hand skill.
Correct. But in this new AI workflow, the machine handles the rendering. It calculates the lighting. It simulates the physics. So what did Razmadrak actually provide?
They provided the idea.
More specifically, they provided the composition and the intent. That bad sketch established the camera angle. It established the placement of the horizon line. It locked in the scale of the barrel relative to the tank body. The AI basically used those wobbly pencil lines as a rigid skeleton, like a control net, and then just painted photorealistic reality directly on top of it.
So the artist is now acting as the architect, and the AI is just the builder. The architect doesn't actually need to know how to mix mortar or lay bricks, but they absolutely need to know exactly where the wall goes.
Exactly. It completely opens the door for people who have that strong mind's eye, the people who can clearly see the cinematic movie in their head, but whose hands maybe can't paint photorealistic HUD, to finally get that vision out into the world.
It effectively separates the job of the director from the job of the cinematographer.
That's the perfect way to phrase it. You're directing the scene with your pencil, but the AI is doing all the heavy cinematography. But, and this is a massive but, creating one single cool transformation of a tank is one thing. That's a neat gimmick. Building a consistent story out of that, well, that is where the real agonizing work begins.
Which brings us perfectly to the Filmmaster paper. Now, this is a heavy piece of academic research. I'm not going to lie, I tried reading the abstract 3 times before I gave up and switched to the simplified breakdown. But at its core, it's using a very simple, very emotional story to prove a highly technical point.
Yes, they anchored all their complex research around the story of the Little Prince.
Specifically, the visual of a blonde boy, a white fox, and a single rose on a rocky asteroid.
And their visual choices in this study are crucial. The paper describes these deep blue star fields, sweeping cosmic winds, and this overwhelming sense of insignificance.
Insignificance. That's such an interesting, deeply human word for a dry tech paper to use.
It really is. But it highlights their core narrative objective. You see, most people, when they open an AI video tool, they type something extremely literal, like boy on asteroid running. That is a motion command, purely mechanical. But the Filmmaster approach argues that to get a masterpiece, you need a narrative command, something like emphasize the insignificance of the characters against the vast universe.
So the AI actually has to understand the underlying vibe.
It has to understand the emotional context of the scene.
Yeah.
And to get it to do that, you can't just throw one image at it and cross your fingers. You need to provide what the researchers call a story of worlds.
Story of worlds. It sounds like the title of a sci-fi novel. What does that actually look like in a daily workflow?
It means you have to acknowledge that a single generated image is just one tiny slice of a timeline that already exists in your head. You can't just animate the single slice. You have to force the AI to understand the whole loaf of bread.
Okay, well, now I'm hungry, but go on.
The researchers basically break the preparation down into layers. First, you have the synopsis. A boy and a fox meet a sad rose. Very simple. Then you build the simplified storyboard, which goes background, cause, development, outcome.
Okay, let's trace that out. So, background would be we are standing on the asteroid. Cause is the rose is sad. Development is the prince decides he wants to give her a star to cheer her up. And outcome is she is delighted.
Right. Now, most casual users completely stop right there. But the Filmmaster system pushes deeper into the detailed storyboard phase. This is where they actually define concrete 5-second cinematic shots. Shot 1, camera zooms in on the prince's wide-eyed wonder. Shot 2, the fox shakes its head to imitate the rose.
This is literally just actual filmmaking. You aren't just typing words and hoping the AI does something cool randomly. You are rigorously scripting the shots.
You are. And this is exactly where the concept of the artist's new canvas really comes into play. You aren't painting a static scene anymore. You are planting the seed of an entire movie. But here's where you hit the wall. You have this beautiful plan, you have your detailed storyboard, you generate shot 1 and it looks absolutely perfect. The prince is cute, the lighting is beautifully moody. Then you go to generate shot 2.
And the prince has suddenly turned into a completely different kid.
Or the rocky asteroid has inexplicably turned into a sandy desert. Or the white fox has turned into a golden retriever.
This is the consistency crisis we were talking about earlier, and I want to drill down into this for a minute because this is the #1 complaint I hear from anyone trying this. Why is it so fundamentally hard for an advanced AI to just keep the kid looking the same?
It really comes back to that dreaming analogy. The AI generates every single frame from scratch, based purely on noise. It doesn't inherently know that the word boy in prompt A refers to the exact same physical entity as the word boy in prompt B. To the AI brain, they are two completely separate mathematical dice rolls.
It's like firing your lead actor and hiring a brand new one for every single shot of your movie. Hey,
Yeah.
scene 2, you're fired, kid. Bring in the next blonde boy.
And when that happens, the audience creates zero emotional connection because the visual identity is totally fluid. You simply cannot care about a character who changes faces every 5 seconds. So how do we actually solve it? The sources point to a few different methods, ranging from basic hobbyist hacks all the way to complex academic systems.
Let's start with the reference image workflow, because this was all over the YouTube tutorials we analyzed, specifically the ones from AI Insights Hub.
This is the absolute baseline requirement today. You cannot rely on text descriptions alone anymore. If you type blonde boy with green scarf, you will get a million slightly different variations of that concept. You need what amounts to a casting sheet.
A casting sheet.
Yes. You have to create a master, pristine image of your character first. And the Reddit guides heavily suggest doing this on a pure white background to avoid confusing the AI with any stray scenery. You generate your prince until you get him looking absolutely perfect. That final single image becomes your seed.
And then every single time you generate a new video shot, you upload that seed image.
You upload it as a rigid reference. You are essentially telling the system, look closely at this image. This is our lead actor. Do not change his face. Do not change his clothes.
The Reddit master guide we read called this the master consistency lock.
Which sounds like a fancy marketing term, but it's really just a highly rigorous prompting strategy. The guide insists on adding very specific phrases to every single prompt you write. Phrases like maintain character consistency, exact same facial features, and use reference image as primary source.
It's basically just yelling at the AI director through a megaphone. Don't change the actor.
Exactly. But even with all that yelling, you still run into massive problems. There was a rule from the duochroma tutorial source that I found totally fascinating. They call it the camera frame rule.
Oh, this rule really tripped me up at first. It says something like, if a character walks off screen in clip A, the AI cannot generate them in clip B.
It seems incredibly counterintuitive to how we perceive reality, doesn't it?
Yeah.
In the real physical world, if I walk out of this room, I'm still just standing in the hallway. I still physically exist.
Right, it's object permanence. Human babies figure this out at like 8 months old.
Well, video AI hasn't figured it out yet. Most of these workflows rely on using the final frame of your previous video to start the new one. So imagine clip A ends with the prince walking completely off the right side of the screen. That final frame is just empty space and stars. Now, you use that empty frame to start clip B. You prompt the AI, saying the prince walks back in from the right. The AI looks at the starting image. It sees empty space. It thinks to itself, there is no prince here. It has 0 pixel data to build him from. So it either outright refuses to generate him or, and this is usually worse, it generates a brand new prince out of thin air who looks completely wrong.
Wow. So simply because he wasn't visible in the pixels, he literally ceased to exist in the universe.
Exactly right. To the AI, if it is not currently in the frame, it is dead.
So you really have to direct your actors to stay on the stage. You literally have to design your shots to keep the subjects inside the frame if you want to keep the narrative alive.
It forces you into this very stage play dynamic. You have to be incredibly careful and deliberate about blocking exits and entrances.
Now, that's the clever hobbyist workaround, right?
Yeah.
But the Filmmaster paper, they're trying to solve this permanently with actual code. They aren't just typing, please keep him in the frame into a prompt box.
No, their approach is much more systemic.
Yeah.
They propose a whole underlying architecture called spatio-temporal aware indexing.
Okay, you are definitely going to have to break that one down for us. That is way too many syllables for a casual deep dive.
Fair enough. Think of it as the AI keeping its own detailed production notebook, an ongoing continuity log.
Oh, like a script supervisor on a movie set?
Yes, perfectly. A digital script supervisor.
Right.
Currently, standard AI video models have no notebook at all. They only have whatever is in the current prompt box. But the Filmmaster system actually creates a separate memory index that tracks the persistent state of the world. It basically writes down time as morning location is the asteroid characters present are Fox on the right, Prince on the left background is Starfield.
So it actually remembers the context that happens between the cuts?
It remembers the global state. So when you ask it for shot 2, it first checks the notebook. It sees location as asteroid. So it inherently...
Well, look who's getting older. Bless your heart,
even if the user
you're
forgot
still
to
a sight.
specifically type the word asteroid.
Though that wild streak dimmed, I recall when your spirit burned so bright. I'm dreaming of when I was young and a messy cowgirl. She wore my name on her belt for 7 days straight. Dreams we'll never forget of a cowgirl named Beatrice.
Is the fundamental difference between a random hallucination and a structured simulation.
That is a massive distinction. A hallucination just drifts endlessly, but a simulation actually has underlying rules.
Perfectly said. And once you establish those rules, once you have a stable stage and a consistent actor locked in, you can finally start to actually direct the movie.
Which moves us into section 3 of our dive today, the director's chair. Because I think a lot of people just assume that AI video simply means making things move.
It's the difference between random motion and directed motion. It's a huge conceptual gap.
Right. I've seen those early viral AI clips. The characters just sort of bob around aimlessly. They blink way too much. The leaves randomly rustle in the background. It honestly just looks like a living photograph from an Harry Potter newspaper. It's technically moving, but nothing is actually happening narratively.
That's what the researchers call the anim director baseline. It's entirely passive. The AI just guesses what might move. But the Filmmaster approach, and honestly the more advanced YouTube guides, are heavily advocating for intentional cinematography. They're talking about specific camera commands like dolly, zoom, truck, and pan.
Yeah, I saw a list in one of the YouTube sources. They actually provided a downloadable text file just full of camera movements for people to copy and paste into their prompts.
It creates a shared vocabulary that the AI actually understands. If we go back to our Little Prince storyboard.
Okay, let's put on our director hats and block this scene out.
Shot 1. We want to show the vast isolation of the kid. We don't just type show the asteroid. We prompt wide sweeping shot of space slow pan across the distant stars.
So we're establishing the scale and the vastness first.
Exactly. Then shot 2.
Yep.
We need to physically find our hero in all that space. We prompt slow zoom in on the rocky asteroid. We are intentionally closing the emotional distance. Then shot 3. We want to connect with his internal emotion. We prompt circle around the prince to slowly reveal his face.
It's basic cinematic grammar. It's a visual language that we've all subconsciously learned just from watching decades of movies.
And here's where the Filmmaster paper gets really, really sci-fi, because they use a system called ARG retrieval augmented generation to actually help the AI choose those specific camera shots.
Okay, now I hear Arge mentioned in tech news all the time, but usually it's in the context of corporate chatbots. Like if I ask a customer service bot about a return policy, it retrieves the actual policy document so it doesn't just confidently lie to me.
Correct. In that context, it retrieves text facts.
But how does retrieving a document apply to a camera moving dynamically through space?
It's the exact same concept, but instead of retrieving boring text documents, it's retrieving cinematic history. Imagine the AI is a highly skilled cinematographer who has perfectly memorized every single movie ever made, but has absolutely zero personal imagination. It can only create by mimicking what worked before.
Okay, I'm with you.
So the system has this massive database of film clips paired with their descriptive prompts. When you tell the Film Master system, I want a scene that feels deeply sad and isolated, it doesn't just guess what that looks like. It actually queries its database. It says, show me the camera prompts from historical movies that were strongly tagged with emotions, sadness, and isolation.
And what does it usually find when it searches for that?
It finds statistical visual patterns. It might analyze the data and realize that in 90% of classic sad isolation scenes, the human director chose to perform a slow pullback, physically distancing the viewer from the struggling subject.
So it literally pulls a proven emotional prompt structure from something like Interstellar or The Martian.
Effectively, yes. It retrieves that specific camera instruction and automatically applies it to your little Prince scene. It says, okay, the user wants the audience to feel sadness, so I will execute a slow dolly out. It's mimicking the deep intuition of a human director just by analyzing the statistical history of cinema.
That is honestly kind of beautiful, but also deeply terrifying at the same time. It's algorithmic emotion. The math literally knows exactly which camera angle makes our human brains want to cry.
It is quantified feeling. But, and this is a critical point raised by the study, even the most mathematically perfect director can get severe tunnel vision.
Ah, yes, the director-only perspective problem.
The study found that if you only let the director AI make all the decisions, it tends to blindly think its very first draft is an absolute masterpiece. It pumps out the rough cut and says, there, it's perfect done.
Which, let's be honest, is incredibly true of human directors sometimes, too. You just fall in love with your own raw footage.
You really do. You completely lose objective perspective. So to counter this, the Filmmaster researchers smartly introduced an audience agent into the loop.
A completely second AI program.
Yes, a second distinct AI layer that acts solely as the viewer. It sits back, watches the newly generated clip, and ruthlessly critiques it.
It reviews the daily footage.
It completely simulates a grumpy test audience. It might look at a generated sequence and say this panning shot is way too boring, cut it shorter, or it might flag an error and say the lighting changed way too abruptly here, it completely ruined the immersion, or the character's face just warped and looks distorted.
So it forms an automated internal feedback loop.
It creates a necessary system of checks and balances. The director agent creates the footage, the audience agent critiques the flaws, and then the editor refines the prompt and tries again. This specific loop is how you get from a weird, morphing AI nightmare video to a highly polished narrative sequence.
I really love the idea that we are effectively just building an entire digital film crew up in the cloud. You have the cinematographer, which is your prompt.
Yeah.
You have the casting director, which is your reference image, the script supervisor running the memory notebook, and now an entire test audience.
It perfectly illustrates that creating a true digital masterpiece isn't just about having a slightly better rendering algorithm. It's entirely about having a better overarching process.
Speaking of process, I want to get down into the actual nuts and bolts for a minute. We definitely have listeners who are itching to try this out tonight. They have that old sketch, they have a cool idea. How do they practically do this? How do they extend their canvas beyond that frustrating 6-second mark without needing a massive supercomputer running this custom Filmmaster code?
For that, we turn straight back to the Reddit experts.
Yeah.
The extend from frame technique is basically the gold standard right now for the everyday hobbyist creator.
Yeah, this comes from the master guide posted by user FindComputer4451 on Reddit. I love that handle, by the way. It's very cryptic.
It is a great handle.
Oh.
And their methodology is incredibly rigorous. It's basically a tight, continuous loop. First, you generate clip 1. Let's stick with our prints on the asteroid. You keep generating until you get a clip you really like. It looks good. The lighting is right.
Okay, I've got my first 4 seconds.
Now, you take the exact final frame of that specific clip. You either manually screenshot it, or you use the tool's built-in Use Last Frame button. That single image then becomes the literal input, the starting seed point for clip 2.
So the absolute end of clip 1 is the direct beginning of clip 2.
Precisely. And the overarching goal here is what they call zero drift. If there is a campfire crackling in the background in the very last frame of video 1, it must be crackling in the exact same pixel location in frame 1 of video 2. If the cosmic wind is blowing the prince's scarf hard to the left, it must immediately continue blowing to the left.
But wait, I can see a massive practical problem here. If I actually do this, if I generate 4 seconds, meticulously take a screenshot, upload it, write a new prompt, wait for another 4 seconds to generate, that sounds incredibly, incredibly
Oh,
tedious.
it is excruciatingly tedious if you do it linearly one by one.
Right, you'd be sitting there all weekend just to get a mediocre 30-second clip.
Which is exactly why the auto-whisk method that was mentioned in the YouTube transcripts is such a massive game changer for workflow efficiency.
Batch processing.
Batch processing. You simply don't work linearly. You open 4 or 5 separate browser tabs of whatever AI generator you're using, grok Imagine, or whatever your tool of choice is.
The pro tip in the guide was literally just open 5 tabs.
It sounds overly simple, but it fundamentally changes the whole workflow. You set up the prompt for the next logical sequence and you fire it off in tab 1. While that server is thinking and generating, you immediately go to tab 2 and fire off a slight variation. You go to tab 3 and try a totally different camera angle.
It's the digital equivalent of having 5 separate easels set up in your art studio. You aggressively work on one canvas while the paint is drying on the other 4.
Exactly. You are mass generating options. Because let's be totally real here, AI is highly random. 80% of what it spits out is going to be absolute unusable garbage. The prince is going to suddenly grow 3 arms. The asteroid is going to randomly explode into confetti. You absolutely need volume to find the gold.
So you're not really directing one movie, you're mining. You're endlessly mining for those rare, perfect 4-second clips that perfectly stitch together.
You are heavily curating. You might generate 20 distinct clips just to find the 3 consecutive ones that actually work.
I want to touch on another really cool example from the sources because it deals with a totally different kind of source material. We talked a lot about the hand-drawn sketch, but what about the vintage postcard example we saw from the duochroma tutorial?
Oh, this is a genuinely beautiful application of the underlying technology. They took a real vintage postcard, the classic greetings from New York style, with the massive block text, huge borders, and maybe some serious yellowing and water damage from age.
Right. A totally static, highly cluttered 2D image.
And they didn't just immediately try to animate it. They actually used the AI to meticulously clean it first.
They digitally restored it.
They restored the hidden world behind the postcard. They specifically prompted the AI to carefully remove all the text and the borders, essentially asking the AI to intelligently fill in the blanks of whatever architectural details were obstructed by the giant letters N-E-W-Y-O-R-K.
That is so fascinating. So the AI looks at the tiny sliver of a brick building behind the letter N and just flawlessly hallucinates the rest of the entire building.
Yes, it seamlessly inpaints the missing pixel data. And once they had a completely clean plate, a pristine, unblocked view of the historical city, then they finally animated it.
And they also specified a distinct artistic style, right? I think the prompt was Hollywood cartoon film still.
Yes. Specifying the style strongly helps the AI understand the underlying physics of the world you want. If you say Disney Pixar style, the resulting movement is going to be very bouncy, utilizing classic squash and stretch animation rules. If you say Ghibli style, as the Filmmaster paper actually suggests, the movement might be much more subtle, focusing heavily on the wind rippling in the grass and lush atmospheric clouds moving slowly. You are literally defining the physical laws of gravity for your universe.
Okay, so we have our video rendering. We have mostly consistent characters. We have beautifully directed camera moves, and we've painstakingly extended it to maybe 30 or 40 seconds using the screenshot loop, but it's completely silent.
The silent film era is long over. We desperately need audio to truly sell the illusion of life.
Which brings us to Section 5, Audio and Atmosphere, the final polish. The source is widely mentioned using external tools like Google AI Studio, using Gemini, or dedicated voice platforms like 11 Labs to handle the voiceover.
VoiceOver is definitely the easiest layer to add right now. You can simply prompt the audio AI with something like, read this script aloud in a warm storybook tone for children. It sets the emotional mood instantly, and it really helps bridge the awkward visual cuts.
But the Filmmaster paper readily admits there is a massive technical hurdle here. Basically the final boss of AI video generation.
Integrating actual dialogue.
Meaning lip sync.
Lip sync is the hardest part by a wide margin.
Yeah.
And it actually goes all the way back to our spatial awareness problem from earlier.
Explain that connection for me. Why is talking so much harder for the AI than walking?
Think about a standard conversation in any movie. You have shot A, which is the prince talking. You have shot B, which is the fox silently listening. Then you quickly cut back to shot A for the prince's reaction. This is standard shot, reverse shot cinematography.
Right, it's the most basic building block of cinema.
But to execute this properly, The AI needs to know exactly where the characters are physically standing relative to each other in 3D space. It needs to know that when the prince looks to screen right, he is making direct eye contact with the fox. When the fox looks screen left, he's looking directly at the prince. Current AI video models really struggle with mapping this 3D spatial layout consistently, so they often just have the characters staring blankly off into the void while their mouths move.
And then there's an actual mechanical mouth movement
The
itself.
lip flap, yeah.
Yeah.
It's definitely improving, but it still often looks exactly like a badly dubbed kung fu movie from the 70s. The mouth generally opens and closes, but it completely fails to hit the hard P and B consonant shapes. It lands squarely in the uncanny valley and ruins the whole effect.
So for right now, the consensus recommendation seems to be stick entirely to narration.
Definitely. A strong narrative voiceover allows you to tell a complex emotional story without ever needing precise frame-by-frame lip sync. It leans naturally into that storybook aesthetic. It feels like an intentional artistic choice rather than a failed attempt at fauteur realism.
Before we look at the final results, there is one last technical tip I want to highlight: upscaling. Anthony Godinho's YouTube tutorial makes a really big deal out of finding the 3 dots menu and clicking the upscale button in Grok.
It sounds like a trivial extra step, but the visual difference is truly massive. Most of these base generators only spit out video at roughly 600 or maybe 700 pixels wide. That's perfectly fine if you're just watching on a phone screen, but if you actually put it up on a computer monitor, it looks like compressed soup. Upscaling forcefully takes it to 1300 pixels or more.
It's the visual difference between a rough pencil sketch and a fully finished oil painting.
But there's a huge warning attached to this step. The expert community note is that you must always heavily download and save the original low-res file before you click upscale.
Why is that? Is it just to have a safe backup?
It's because upscaling itself involves another layer of AI guessing. It is actively adding thousands of pixels that were never actually there. So it looks at a blurry brown patch and confidently thinks, oh, maybe that's an eye. Let me draw an eye there.
Oh man, sometimes it guesses completely wrong.
Sometimes it hallucinates horribly. It might decide to turn a blurry patch of texture on a rock into a creepy human face. Or it might aggressively sharpen a character's nose until it looks pointy and unnatural. You always want the raw, fuzzy backup saved just in case the final polish completely ruins the painting.
That is extremely practical advice. Always keep the negatives. So when you put all of this staggering amount of work together, the consistency locks the specific camera language, the tedious frame looping the audio layer. What do you actually get? What does the perfect outcome look like?
We return to the Little Prince case study. The sources detailed a highly successful generated sequence where the prince finally gives the rose a star.
I can vividly picture it.
The camera cuts to an extreme close-up of the prince's small hands. He's gently holding this glowing, ethereal star. The soft light of the star realistically reflects on the fox's white fur, which is continuously rippling in that exact cosmic wind we established way back in shot 1. Then the fox adorably imitates the sad rose to try and make her laugh.
That requires so much subtle narrative nuance. The fox actually has to look directly at the rose, understand her internal sadness, and deliberately perform a physical action to change her emotional state.
And the AI camera perfectly captures it with a slow dolly in, Doug, to really emphasize the quiet intimacy of the moment. That right there is true emotional resonance. That is actual storytelling. It's no longer just Fox moves head, it's Fox comforts sad friend.
That right there is the deep dive mission fully accomplished, taking the cold, static image and finding the warm, beating emotion hidden inside it. But on the totally flip side of that, we have the Statue of Liberty example from the AI mastery source.
A completely different tone.
She swims. The prompt they used is just hilarious. The massive copper statue does this incredibly awkward doggy paddle right in the middle of New York Harbor and then abruptly takes off and flies over the city.
Complete with cartoon thought bubbles popping up saying, "Who knew I could fly?"
It's totally absurd. It's silly. But why does a goofy video like that matter as a technical success story?
It perfectly demonstrates the incredible range of the medium. The exact same AI tool that painstakingly creates the poignant, lonely, heartbreaking atmosphere of the asteroid can easily pivot to create a slapstick comedy starring a giant copper monument. It proves that the human director can forcefully impose a specific genre on the machine. The AI inherently doesn't have a sense of humor. The human user provided all of that.
And then there's the sheer blockbuster spectacle, the Godzilla versus Cybertruck scenario mentioned in the guides.
The ultimate physics demo.
A fierce heavyweight battle out in the desert, swirling dust-heavy, stomping footsteps.
This one demonstrates weight, mass, and collision. The Little Prince is all about delicate atmosphere, but Godzilla is all about raw kinetic impact. The AI actually have to understand that when a giant radioactive lizard steps down, a massive plume of dust must realistically rise. If the heavy Cybertruck speeds away in a panic, it has to leave a deep physical trail in the dirt. The Filmmaster continuity notebook approach helps the AI remember, wait, we are currently in a desert. There's an active sandstorm happening which keeps that swirling dust perfectly consistent across multiple dramatic camera cuts.
It really feels like we are standing at the absolute edge of an entirely new artistic medium here. We aren't just drawing static pictures anymore. We aren't even really just animating them. We are fully orchestrating living worlds.
Orchestrating is the absolute perfect word for this. The solitary artist is rapidly becoming a grand conductor. You aren't physically playing every single instrument yourself anymore. You aren't painfully drawing every single pixel of the mud on the tank tracks or every star in the sky. But you are the one directing the symphony. You are the only one telling the emotional violins exactly when to swell and the heavy drums exactly when to crash.
And I really want to end our dive today on this specific thought because it really stuck with me from reading the Filmmaster paper. There is a massive catch to all this power.
There is always a catch with this technology.
The researchers explicitly mention that a, quote, director-only perspective hampers effective correction, unquote.
Right. The AI fundamentally thinks its output is always good. It lacks all self-awareness. It doesn't actually know when a visual cut feels slightly awkward. It doesn't feel it when a sweeping shot drags on just a few seconds too long and gets boring.
It can brilliantly generate the pixels, but can it actually generate the taste?
That is the ultimate provocative question going forward. We can mathematically build an audience agent to ruthlessly check for technical flaws to scan the frame and say this corner is too blurry. But can a piece of code truly understand human pacing? Can it ever understand visual irony? Can an algorithm know exactly which millisecond to abruptly cut to black just to completely break the viewer's heart?
I really think that's where we, the humans, are still entirely essential to the process. The AI is the expensive camera, it's the tireless lighting crew, it's the incredibly fast set designer. But we are still the editor. We are the only ones who can actually feel the story.
We provide the soul. The AI merely provides the simulation.
So here is my final challenge to you listening right now. Go dig through your closet and find that old forgotten sketchbook. Find that bad wobbly drawing of a tank or that goofy doodle of a superhero you made up in high school. Or just take a favorite old photograph that has a whole forgotten world trapped behind it.
Scan it and upload it.
Use that rigorous extend from frame loop technique. Really try to push it way past that frustrating 6-second barrier. Try to make it breathe and live. See if you can actually step back inside that world you imagined all those years ago.
See exactly where the story leads you when you let go.
And when you inevitably hit that brutal consistency wall, and trust us, you absolutely will, just remember the notebook. Strictly remind the AI exactly who is standing on the stage.
And always keep the camera moving.
Thanks for diving deep with us today. We'll see you in the next world.